Alright, here we go. We are exploring something called partial fractions. Partial fractions. What partial fractions do? Partial fractions, that phrase is actually an algebraic phrase. It's a form of algebraic manipulation that is going to allow me to break down complex integrals into something a little bit more simple to solve. I'll come around and collect a little bit. Thank you, though. It is breaking down fractions based off of factors in the denominator. I'm breaking down fractions, so big complex fractiony boys, and I'm turning them into something a little bit more nice that hopefully I will be able to integrate. Now, yesterday I gave you the idea of when you should use integration by parts. I'll give you the idea of when you should use partial fractions. I'm going to use this method when I have a denominator in factors. So if I have something like the denominator is 1 over x plus 2 and x plus 8. If you're ever given something like that, that's an indication that we should probably use some partial fractions. Or if I have a denominator that is factorable. So something like 1 over x squared minus 6x plus 5. That trinomial down there is definitely factorable. And we're going to need to remember a little bit of our factoring as we're going through here. It's not going to get too complex, but we need to remember some of it. Dig? Alright. So let's look at the process of this. The first one, I'm going to write out pretty much every single step, which you don't necessarily need to do as you're going through this. I just want you to see, okay, that's where that's coming from, and this is why I'm doing this. So example 1. Again, when I did this earlier in last period, it took me pretty much the entire page. So give yourself a decent amount of space as we're going through this. We're going to look at this integral. The integral of 4x plus 1 all divided by x squared minus 5x plus 6 dx. Now, I've been hitting this as I go along, and we should continue to think about this. You need to have sort of a hierarchy in your brain of what I should try. We're actually, I think this is the last day that I'm going to introduce a new integrating concept. We have 2 more that we're not going to talk about until after the AP test because they're not on the AP test, and they're rather complex. It's integration using trig substitution and trig integrals. Those things don't show up on the AP test, so we're going to leave until after the AP test. It's something we need to know for calculus reasons and you moving past this class, but we're not going to focus on it right now. We're going to focus on what's on the AP test. Cool? What you need to prioritize in your brain, the order that you go in, that we have been looking at. First, I need to see if there's an identity that I can use. In other words, the pink cards. Is there a pink card that relates to this problem right here? No, it doesn't really look like an arctangent. I'd have way more stuff going on. In fact, I have this 4x business on top. It's not natural log. There's nothing I can do. So the next thing I'm going to go to is u sub. Sort of. The rule that I gave you is if there's an x squared and an x component, maybe they will cancel. If I took a u sub of the bottom, the derivative of this part, what's the derivative of x squared? 2x. What's the derivative of 5x? So I have 2x minus 5. is that going to cancel with a 4x plus 1? No, it's not. I have to have a singular x to cancel out with things there. So that's not going to work out. My u sub gives me a sad face. The next thing we talked about was some long division or completing the square. In this case, which is bigger, the numerator or the denominator? Denominator, so I don't need to do any long division. Completing the square, I don't see that I have any, like a 1 on top. This 4x plus u business right here is maybe going to prevent me from doing that. So I can't do any completing the square or any business like that. So the last one that we learned yesterday was integration by parts. And I told you integration by parts we use when I have multiplication of two separate functions. Do I have two separate functions in this case? Yes. Yeah, but do I have two different types of functions? No, functions. No, I don't. Remember, yesterday we were looking at things that was like x squared and e to the x, or x cubed and sine of x. I don't have two different types of functions like I did yesterday. I have two polynomials. Well, a linear and then a polynomial. So I've exhausted all my options. I'm going to something called partial fractions. And what I'm going to do is I'm going to take this business right here and I'm going to break it up into component fractions. It's actually an algebraic technique that will allow us to work a little bit easier. So I have this. My fraction I'm looking at right now, 4x plus 1 over x squared minus 5x plus 6. Does that factor? Does that bottom factor into anything?
X minus 3.
Right. I think this will factor into, I'm going to have a 4x plus 1 still on top, but now I'm going to have an x minus 3 and an x minus 2. Now, I have no way of integrating two things that are multiplied, right? I do have a way of integrating things that are added or subtracted. Like x squared plus 2x, I can integrate each part. I can't integrate x squared times 2x unless I simplify it. So I'm going to basically work my way backwards, and I'm going to say, great, what if I could split this up into separate fractions that are added based off of these two parts? Now, I have no idea what is going to make this true, so I need to put something up here. There's some numbers up here that will make this true. Don't know what they are. Hopefully I can find out what they are. So I'm basically going to take this, I'm going to split it up into two fractions as I'm going through there. Alright, well, I have something over here and then two parts over here. I'm looking at the top and I want to figure out what this A and B are. So I'm thinking I'm going to want to make some common denominators through here so that I can set all this business equal to each other. Let's look at this one first. What would I need to multiply top and bottom so that this has the same denominator as what I started with? X minus 2. So I'm going to multiply the top and bottom by x minus 2. What about the last part? What would I need to multiply that by?
X minus 3.
Right. This is missing an x minus 3 on bottom, so I'm going to multiply top and bottom by x minus 3. So all told, this now becomes 4x plus 1, all divided by x minus 3, x minus 2, is equal to, on top, I have a x minus 2, divided by the now common denominator, x minus 3, x minus 2, plus b, x minus 3, all divided by x minus 3, x minus 2. So I found a common denominator. It stands to reason that if all of the bottoms are the same, that the top has to also be equal to each other, right? If the bottoms are equal, the tops have to be equal to each other. So now I'm left with an equation that says 4x plus 1 is equal to a x minus 2 plus b x minus 3. I'm just going to ignore the bottoms now because they're all the same. And again, relate this back to the whole overarching goal of what I'm trying to do. I'm trying to figure out what numbers would make this true. So I'm trying to figure out what a and b are so that I can split this complex fraction into two separate, little bit smaller fractions. I'm decomposing what that fraction is. Any ideas on what I could do with this newfound equation to find out what a and b are?
Wait, why are you doing them together?
Because it was one big equation where it's equal to each other. I just took the entire top and set it equal to each other.
You don't know what find the derivative. If you do that, the derivative is going to be double of what?
Wait till I get to the end. You don't need any derivatives in this case at all.
But when you don't know what to do, you find the derivative.
No.
No, wait, did I say derivative?
Yeah.
I meant denominator.
Denominators. Okay. So say your question again, then, Jacob.
So like the denominator is going to be doubled because you're adding two of the same thing when it's supposed to be.
No, I'm adding fractions. Right. Look at this. If I add 1/4 plus 2/4, it's not going to be 3/8. We're good. Idea? What was it for finding these?
Can you find B in terms of A and X and go back to
Yeah, I think there's a way more elegant way to do that, though. All right. I'm going to be sort of sarcastic with you and see if you can pick up on the sarcasm. I'm going to pick a random number. I'm going to pull a number out of my butt and see what happens. I hate that number. I'm not going to use that number. I like 2. 2 is a really good number. 2 and 3. Oh! Aiden is picking up on my sarcasm. I'm going to start by plugging in random number, maybe a 2. Let's see what happens. I plug in a 2 into this equation. I have 4 times 2 plus 1, a 2 minus 2, b 2 minus 3. So, let me simplify it, see what I got. 4 times 2 plus 1, that's 9. 2 minus 2, what would you look at that? 0 times a, the a disappears. And then I have 2 minus 3, that's a negative 1, so I have negative b.
Well, like why? Can we just do that?
Yeah.
Plug in random numbers to find it out?
Yeah, I can do that.
Oh, the cross out denominator.
I'm trying to solve. Dude, Claire, you sounded so attacked. You're like, but why?
I'm going to be really sarcastic to you guys.
So, this b value, I'm divided across by that negative 1. B is equal to negative 9. Again, let me try a random number. I'm just plugging in numbers to hopefully figure out, right, because this is an equation that has 3 variables in it. I'm trying to figure out what a, b, and x are as we're going through there. So I'm going to plug in a 3 now. The reason I'm choosing a 3, hopefully you're picking up on it, a 3 minus 2, 3 minus 3, so that 3 is going to cancel, allowing me to solve for the other letter. There we go. So, settle down, Peanut Gallery. Yes, sir. Yeah, you'll see in just a minute. 4 times 3 plus 1, 13. A, 3 minus 2, that's going to be 1a. 3 minus 3 cancels, that b goes away. So I have a is equal to 13. Now, I'm not out of the woods yet. I have just done one part that sort of in your brain might not make any sense yet. Here's where I'm going to throw this together. Again, One more time. The whole purpose of this was trying to break up this fraction so that I find out what its two component parts are. Because right now I have no way to integrate it. Now I have turned what I started with into a brand new integral. I've turned it into this. A was 13, so this is 13 over x minus 3 plus negative 9 over x minus 2.
How did you know it was over x minus 3?
Because A at the beginning was over x minus 3 and A was 13.
Hey, why'd you get rid of the other stuff?
What other stuff?
He's talking about the other
Denominator.
denominators.
Because I am using this is an algebraic technique to take this fraction and break it up into these two fractions. I'm just using algebra and common denominators to do that. So, from here, I can integrate this now pretty easily. The 13 is a coefficient. It goes up front. So 13, the integral of 1 over x minus 3. The negative 9 is a constant, so I can put it up front. Minus 9, the integral of 1 over x minus 2 dx. Now, I don't know this off the top of my head, but hopefully you're seeing that there's a tendency. I can do a very, very easy use of. U is going to be the bottom, x minus 3. So du is going to be dx. U over here is going to be x minus 2. So du is going to be dx. So these integrals turn into 13, the integral of 1 over u du, minus 9, integral of 1 over u du. And now I've finally boiled it down to option number 1, where I can use an identity. What is the integral of 1 over u? ln. So this is 13 ln of whatever my u was there, so that was x minus 3, minus 9 ln x minus 2 plus c. Partial fractions is a way of taking fractions, decomposing them into simpler fractions that are added or subtracted so that I can integrate them. Alright, I need you to try one on your own for this to sink in. Here's the one I want you to try on your own. Here's the one you're trying. Alright, I'll give you a head start on this one and then I'll tag in after this. I want you to try it on your own, please. Just so the recording has the answer, it was 7 ln of x minus 2 minus 3 ln of x plus 5 plus c as we're going through there. Alright, so let's look at a different way to do this one. There's another type of this partial fractions that has to do with something called repeating linear factors. Here's our next one we're going to do.
There's a repeater in Minecraft.
The integral of 4x squared plus 2x minus 1 all divided by x squared x minus 1. dx. You cannot. No. The top is bigger than the top is smaller than the bottom.
Okay, thank you.
You're welcome. So, there is something called a repeating linear factor in this one. I'm going to do the same thing, but to your eyes right now, there's only two things on bottom. There's actually three that are repeated there. Anytime you have something that is raised to an exponential power, you need to repeat whatever is there until you get to the highest power. If you want to know more about the why for that, go look up partial fractions. I'm just telling you that's part of the process of how you're going to break down a fraction. For you, that's nothing crazy. It just means that this is going to turn into one fraction is going to be an x with just a lone ranger x, plus the next factor is going to be x squared plus the other part. So it's A, B, and C. What I mean by repeating linear factor is if you had, this isn't a problem, just showing you a corollary to this. If you had x plus 2 to the third power times x plus 4. If I were to separate that via this idea of repeating linear factors, this would factor into x plus 2, then an x plus 2 squared, then an x plus 2 cubed, plus x over 4. I'm saying you repeat the linear factor until you run out of powers as you go through there. So this is x and then x squared. If it was this, it would be x plus 2 squared, x plus 3. That accounts for every iteration that you can have for that linear factor depending on its exponential power. You just keep repeating it.
X thing with the power in the equation?
You just repeat it until you get to its exponential, its highest exponential power.
So it's like x cubed, x squared, x, and then
right.
a number. You have to do it for...
Right. You just do it each time. Cool?
That could be so long.
You won't get anything that gross of what you just thought in your head. Great. So, the process is still the same. I need to find all these letters. The common denominator that I'm always going for is what you started with. What you're starting with is the common denominator that I'm trying to find. So what do I need to multiply top and bottom so that this denominator looks like that denominator?
X and x minus 1.
Right. So I'm going to have A times x minus 1. Now, I'm going to skip the part in the middle where I put one giant fraction equal to the giant fraction because I already know what I'm doing in there. What do I need to multiply this by, top and bottom, so that this denominator matches my original denominator?
X and x minus 1.
Not an x. An x squared is already there. I only need to include an x minus 1 so that it has a common denominator. What do I need to multiply this by so that it has a common denominator? Just an x squared. Now, the things I just multiplied by will make the top equal to the bottom. So this is all equal to whatever was left over on top. So 4x squared plus 2x minus 1. And now I have to go about choosing some numbers, plugging and chugging, guessing and checking, to see what will I cancel out to go through there. What's a number that I think will cancel things out? 0 and 1 are my pretty easy ones. Let's start with a 1. X is equal to 1. We'll cancel out some things, so I have A, 1 times 1 minus 1, B, 1 minus 1, C, 1 squared, is equal to 4 times 1, which is 4, plus 2 times 1, which is 2, minus 1. The 1's will cancel here, so the A is gone, the B is gone. I'm left with C times 1, which is just C. It's equal to 4 plus 2 minus 1 will be 5. The other number you threw out was a 0, I believe. Plug in a 0 into all of this. A times 0, 0 minus 1, plus B, 0 minus 1, plus C times 0 squared is equal to 4 times 0 is 0, 2 times 0 is 0, so I have negative 1. What's up, Aiden?
For the oh, never mind.
Cool.
I'm tripping.
0 times negative 1 doesn't matter what that is. It'll cancel out. B times 0 minus 1, that will be negative 1b, so negative b. 0 squared cancels that out. It's equal to negative 1. So b is equal to 1. Great. At this point, I've exhausted my options for figuring out what for plugging in numbers that will cancel things out.
How big is X positive?
Negative 0 minus 1 is negative 1. So negative b, negative 1. Divide by a negative 1, it turns into a positive. I've exhausted my list of being able to just plug in numbers and figure out what's going on. Thoughts on what I could do? Right, I have B and C. Does it matter what X I choose? No, I can literally choose anything I want now as long as it's not these two so that things cancel out. So what number do you want to choose? 2. Let's start with the next easiest. So, no, not pi. So A, 2 minus 1. My B value, I know my B value is 1 times 2 minus 1 plus my C value, which I know what was 5 times 2 squared is equal to 4 times 2 squared plus 2 times 2 minus 1. Yeah, again, this is why I'm saying I don't think this process is very technically difficult. There's just a lot of little things you have to do to get it done. 2 minus 1, 1 times 2, so I have 2a. 2 minus 1, 1 plus times 1, that's plus 1. 2 times 2, 4 times 5, that's 20, is equal to 2 squared, 4. 4 times 4, 16, plus 2 times 2, so 20 plus a 1, that's going to be 21. Minus 1, that's going to be 19, sorry. So I have 2a plus 21 is equal to 19. Move the 21 over, that is 2a is equal to negative 2. So a is equal to negative 1. Aiden asked me a little bit ago, am I always going to get natural logs through this? Not necessarily. And this is where a case is going to show up where not every single partial fraction is just going to turn into a natural log. I turned this fraction into a fraction with a, b's, and c's. So this is the integral of a over x. My a was negative 1, so I'm going to pop out that negative in front. So 1 over x dx plus b, which was 1, so conveniently I can just plug it in, 1 over x squared dx plus c. C was 5. I'm going to throw that c up front, so 1 over x minus 1. Some of these are very easy to do. In fact, the first one popped out as a straight identity. What is the integral of 1 over x? ln. So I have negative ln of x. Everyone cool with why I have a negative in front of there? My a value was negative 1, so I threw it up front. Yes, Leo? Now, this one, this middle one, if you tell me that this is the natural log of x squared on a test, I will likely get more upset with you and take more points than is rational for me being a teacher. There's no u sub you need to do. It's a negative exponent. This is the integral of x to the negative 2. So I can use my reverse power rule. I increase the power. So that's going to be plus x to the negative 1 divided by negative 1. This one, yeah, that's a natural log one. So I integrate that. That's going to be plus 5 ln x minus 1. Let me rearrange and add my plus c at the very end. This is going to turn into, I'm going to put the positive thing first just because I like how it looks. 5 ln x minus 1 minus ln x minus 1 over x plus c. So, all told, that is my final integration using integration by parts.